Hello everyone, welcome to this interesting video on blockchain in-depth tutorial. Blockchain is a groundbreaking technology that enables anyone to track transactions on a distributed digital ledger without a central authority. So this video will explore various important aspects of blockchain and their related concepts in depth. But before diving deep into its concept, we will first explore the basics, starting with what blockchain is. Features of blockchain like public distributed ledger, encryption, proof of work, mining, smart contracts, and its use cases that will make your base even more stronger. Then we will dive down deeper into its internal concepts and learn about the candidate block, Byzantine fault tolerance, the addition of two blocks at the same time, forks like soft fork and hard forks, areas where blockchain is used, what is the future of blockchain, and then we will have a peek at blockchain jobs available. Following these, we will understand why we need blockchain and its real-world applications in healthcare, government, blockchain in KYC, trade finance, mortgage industry, loan management, blockchain in e-Estonia, energy markets, block media, travel, supply chain, and network security like Korea Telecom. Then we will see how to become a blockchain developer, the salary offered to them, and companies hiring blockchain developers to boost your confidence. By the end of this video, I can assure you that all your blockchain related concepts will have been cleared. For this training with me, I have our experienced specialists Sam and Rahul. Together we'll walk you through the different crucial blockchain keynotes and concepts. So let's start with an exciting video on blockchain in-depth tutorial. But before we begin, make sure to subscribe to our YouTube channel and hit the bell icon to never miss an update from Simplilearn.
Ever wonder if there's an easier way to complete transactions without having to deal with online wallets, banks, and third-party applications? Well, it's possible thanks to blockchain. Here's everything you need to know about blockchain. Imagine four friends, Jack, Ted, Sam, and Phil, meet up for dinner. After they're done, Jack pays the bill, and all of them decide to split the expense amongst each other. Now, on the next day, when Phil sends his share to Jack via online money transfer, the transaction goes through without a hitch. Then, Ted and Sam send their respective shares to Jack, but their transactions don't go through. The failed transaction cites some issues at the bank. That's when Jack comes to know about the many ways a bank transaction could fail. It could be due to technical issues at the bank, one of their accounts were hacked, daily transfer limits being exceeded, and sometimes additional charges, like transfer charges, associated with transferring money. To solve these problems, the concept of cryptocurrency came into existence. Cryptocurrencies are a form of digital or virtual currency that run on a technology known as blockchain. Thanks to blockchain, cryptocurrencies are immune to counterfeiting, don't require a central authority, and are protected by strong and complex encryption algorithms. And in a market of more than thousands of cryptocurrencies like Litecoin, Ethereum, Zcash, and so on, one reigns supreme: Bitcoin. Now, let's go back to our previous example and have Phil, Ted, and Sam send Jack 2 Bitcoins each as their contribution to the previous night's dinner. Let's assume Phil, Ted, and Sam have 3 Bitcoins in reserve, while Jack has 5. First, Phil sends 2 Bitcoins to Jack. A record is created in the form of a block. The transaction details between them is permanently inscribed in this block. This record also holds the number of Bitcoins each of the friends own. So, after Phil's transaction, Jack has 7 Bitcoins, while Phil has 1. Following this, Sam and Ted send 2 Bitcoins to Jack. A new block is created for each of these transactions. These blocks hold the transaction details as well as how many Bitcoins Sam, Ted, and Jack have in reserve. These blocks are linked to each other, as each of them takes reference from the previous one for the number of Bitcoins each friend owns. This chain of records, or blocks, is called a ledger, and this ledger is shared among all the friends, which acts as a public distributed ledger. This forms the basis of blockchain. So, what happens when Phil has only 1 Bitcoin left, and he tries to send 2 more Bitcoins to Jack? The transaction will not go through. This is because all his friends have copies of the ledger, and it's clear that Phil has only 1 Bitcoin left. his friends will flag this transaction as invalid. A hacker will not be able to alter the data in the blockchain because each user has a copy of the ledger. The data within the blocks are encrypted by complex algorithms. All of this is made possible with the help of blockchain technology. Blockchain can be described as a collection of records linked with each other, strongly resistant to alteration, and protected using cryptography. Now, let's have a closer look at the Bitcoin transaction between Jack and Phil and find out how it works. Every user in the Bitcoin network has two keys, a public key and a private key. The public key is an address that everyone in the network knows of, like an email address of a user. The private key is a unique address that only the user has knowledge of, something like a password. First, Phil passes the number of Bitcoins he wants to send to Jack, along with his and Jack's unique wallet address through a hashing algorithm. All of this is part of the transaction details. These details are encrypted using encryption algorithms and using Phil's unique private key. This is done to digitally sign the transaction and to indicate that the transactions came from Phil. This output is now transmitted across the world using Jack's public key. With this, the message or transaction can be decrypted only by Jack's private key, which only Jack has knowledge of. Different cryptocurrencies use different hashing algorithms. While Bitcoin uses the SHA-256 algorithm, Ethereum, which is also a famous cryptocurrency, uses one known as Ethash. This transaction and several other similar ones are taking place all around the world. These transactions are validated and then added block by block. The people who validate these blocks are called miners. For a block to be validated and added to a blockchain, miners need to solve a complex mathematical problem. The miner who solves this first adds the block to the blockchain and is rewarded with 12.5 Bitcoins. The process of solving the complex mathematical problem is called proof of work, and the process of adding a block to the blockchain is called mining. With this, Phil and Jack's wallets are updated, just like every person in the network who has completed a transaction. Now that you know about blockchain and its important concepts, time for a small quiz. What is the concept of blockchain that ensures data cannot be altered by any of the users within the network? A. Public distributed ledger. B. Proof of work. C. Proof of stake. D. Hash encryption. Let us know what you think is the right answer in the comments below. 3 lucky winners will get Amazon gift vouchers. Details are mentioned in the description below. Let's have a look at how Walmart uses blockchain to provide its customers with better service. Walmart was facing problems in delivering quality products to its customers. They were facing a high return rate and large amounts of refunds due to their products' bad quality. They were unable to determine the point of failure in the supply chain, which started from farm to storage to transportation to processing all the way to the customer. Then, Walmart adopted blockchain technology. With blockchain, the quality of the goods at each step was permanently inscribed within a block. For example, when a customer flags a product as damaged, it can be correctly identified where the product got damaged in the entire supply chain, thus helping Walmart to identify the problem areas and fixing them. And this is just one of several ways blockchain is used in real-life applications. Can you think of any others? Let us know in the comments down below. That's all for now.
Hello everyone and welcome to this session of Blockchain Tutorial Part 1. My name is Saurabh and I am part of the Simplilearn team. So let's get started and understand what's in it for us today. So let's take an hypothesis. In a city not so far away, somebody was up to something bad. So there is a hacker who hates the bank, who wants to steal the money of all the people lying in the bank. Now, here's why I hate them even more. What are the nuances and the problem areas of the banking system? The banking system has higher transactional and international transfer costs. A lot of documentation is required for setting up of an account, for opening an account and onboarding a customer. And the banking system is not always accessible. It's not 24/7. It's closed on banking holidays, and it has other limitations also, like transfer limits in a day, and you can't transfer X amount within a stipulated time. Now, banks in such an ecosystem acts as a center point of failure. It is a centralized based system which is prone to failure from a centralized point of view. So if the bank fails, all the transactions will come to an halt which are dependent on the bank. Now let's see what happens if the hacker is able to get into the banking system and hacks the bank. All the investors or the people associated with the bank, the information associated with them will get corrupted, will get jeopardized, and it can lead to huge losses to the bank and to the individuals. And all this can happen with a click of a button. It's as simple as that. So once a hacker has access to the system, he can manipulate the system, compromise the information, share it with the parties which are not supposed to have that information, and lot can go wrong. Though the hackers can be caught, right? It is possible through cyber security and various means. But once the information is compromised, it is very difficult to roll that back. And that's why we need more secure systems and systems which are not dependent on a centralized authority, which work in a more decentralized fashion, thereby making it hack proof plus lowering the transaction cost also. Now, this incident, of course, will catch the bank manager's attention. Now, he will go to his advisors and want to make sure this does not happen again. So, the technology people, the advisors will make sure that this does not happen. But what is the remedy? So, the remedy is setting up a blockchain. Now, of course, the manager who's looking into the banking functions might not be aware of the technology and what benefits blockchain bring onto the table in order to prevent such an incident. So that's what we are here for. We will learn before we go and understand what can blockchain actually achieve for us. So we will understand today what is blockchain, the Bitcoin story, the features of blockchain like public distributed ledger, the hashing encryption, the proof of work consensus algorithm, and the concept of mining. And then we will cover up a use case where how blockchain can be used for banking operations. Now, what is blockchain? Blockchain is a list of records called blocks which stores data publicly and in a chronological order. And the entire information is persisted using cryptography. It is secured using cryptography. So cryptography ensures that the privacy of the user is maintained and data cannot be altered. Information on a blockchain network is not controlled by a centralized authority. So unlike modern financial institutions, nobody controls the data within a blockchain. The data is maintained by the participants of the network, and they are the democratic authority in order to approve any transaction which can happen on a blockchain network. Access to anyone on the network. So a typical blockchain network is a public blockchain. So as long as you have access to the network, you have access to the data within the blockchain. If you are a participant on the blockchain network, you will have the same copy of the ledger which all other participants have. So therefore, every participant on the network has the same copy of the data. So everyone in the network has a copy of the blockchain data, which is used for ensuring that data remains untampered. So even if one node or data on one particular participant computer gets corrupted, the other participants will come to know immediately that this particular instance or node has gone corrupted, and they will rectify it as soon as possible. So basically, the question is this the same technology that Bitcoin works on? And the answer is yes. Bitcoin could not have been possible without blockchain. So we will understand how Bitcoin adopted blockchain in order to reach to its journey today. So Bitcoin was introduced in 2009 by someone or a group of people known as Satoshi Nakamoto. It aimed to solve the problem faced by fiat currencies with the help of blockchain technology. Now, as of today in 2018, there are more than 1600 cryptocurrencies that follow the concepts of Bitcoin and blockchain. For example, the other popular cryptocurrencies are like Ethereum, Litecoin, Dash, Ripple, and many more. Now let me explain how a Bitcoin transaction works. The sender transmits the transaction details worldwide. Basically, whenever a sender has to do a transaction, he has to send Bitcoins to a receiver. He will submit the transaction on the public blockchain network of Bitcoin and transmit it. Now, verification to authenticate users, it is done by the miners around the world. So basically, there are specific participants in the Bitcoin network which are called as miners, whose job is to verify the authenticity of the sender and the receiver, and also validate whether the sender has the right amount of balance for the Bitcoin which he is trying to send to the receiver, and ensuring that the sanity of the underlying blockchain network to the Bitcoin remains correct and not get corrupted. So once the miner has authenticated the transaction, verified all the parameters, the transaction is added to a block, and then that block is made part of the main blockchain. Once the block is added to the blockchain, the money, the transactions which were associated in the block then gets executed. Money is deducted from the sender's wallet and is added to the receiver wallet thereby. Once the transaction is completed, the block is added and the ledger across all the nodes are updated. Each and every participant ledger copy is updated with that particular block which has been added in the blockchain. So therefore, all the participants have the same copy of the information. Now, so what makes blockchain special? Now, these are the special 4 features of blockchain which we're going to talk about in detail. It is a public distributed ledger. It works using a hashing encryption. Each and every block has a hash value, which is the digital signature of the block. All the transactions are approved and verified on the blockchain network using proof of work consensus algorithm. And the blockchain network utilizes the resources of the miners who are there to validate the transaction. And the miners, in lieu of investing in their resources and validating the transactions, get rewards in terms of Bitcoin, and that process is called mining. Now, public distributed ledger. So let's imagine 4 friends sharing a particular document amongst each other, correct? Now, if there was only a single copy of that document and one of them altered the data, it may go unnoticed. However, the outcome would be different if each one of them had a copy of the data. So therefore, if each and every participant has the same copy of the data, even if one of them changed the data, the others would find that the data does not match with their own. So blockchain works in a similar fashion. The data within a blockchain is accessible to everyone. So with this, as long as you are part of the network, you could access the entire history of transactions that have taken place since the blockchain was created, since inception. And the first block in any blockchain is called the Genesis block. So from the Genesis block to the current block, you will have the access to the entire chain. Any additions to blockchain have to be approved by the participant users in the blockchain network. So a majority of the members within the network have to approve of any additions to the blockchain. This is the public part of the ledger, and this is important because any additions made to the blockchain are permanent and are immutable. So immutable transactions are the transactions which cannot be altered. Once registered, they cannot be modified and are available for audit and verification 24/7. So this means that each and every detail is recorded and any alterations can be detected by verifying it against everyone's personal version of the blockchain. So if someone's tried to modify a data on a block on a particular node, then the other ledgers which are having the same information will come to know that someone has modified data on a one particular node, and they will try to rectify it. And the fourth property, no central authority is controlling the working of this blockchain network. It is a decentralized network. So this is where being decentralized helps. Everyone has a copy of the blockchain, which means there is no central point of failure. There is a single source of truth. Even if things go wrong, the data can be recovered. If one node goes wrong, the data can be recovered from other nodes. But what about security? How is privacy maintained if everything is so public? And here hashing encryptions comes into picture. It takes care of that. So now we will talk about the second feature, which is hashing encryption. But to understand hashing encryption, we need to understand the contents. What are the contents of a block? So a block in a blockchain is like a container that holds aggregated transactions. It contains certain set of transactions. So we will see what all things construct a particular block. So a block has two parts. It has a header and it has the second part is the transaction details. It is the set of transactions which are aggregated in this block. Now the header has following set of attributes. It has the block version number. It has the hash of the previous block to which it is linked, the current timestamp, the timestamp at which the block was verified, the nonce, we will see what is the attribute, what is the meaning of nonce, and the target value. Now, the transaction details are nothing but the example which we talked about earlier. It is the transaction which the sender and receiver are sharing. The sender is trying to send certain amount of Bitcoin from his account to the receiver's account. Now, it is represented in the form of a 256-bit hash value in the header called as Merkle root or the hash root. So basically, the Merkle root is the hash of all the transactions structured in a Merkle tree called binary tree. It's a kind of a binary tree, and the hash value of the root node of the Merkle tree is called the Merkle root hash. So the transaction details of a block are contained in the header in a hex value known as Merkle root. The Merkle root can be calculated in this way. So basically, the list of transaction, each transaction is passed through a hashing algorithm. Then all the hashes of the transactions are paired and then again passed through another hashing algorithm until only one value remains, and which will be the root. Now let me tell you how a hash function works. Blockchain utilizes a hash function to perform cryptography. Data from a data set of random size is sent as input to a hashing function to get an encrypted value of fixed size, and that is the feature of any hashing function. So some unique properties of hashing function are, these are deterministic. The same input will always produce the same hash output. Small changes in the data can drastically change the output. Basically, any small change to the input produces an output that's drastically different from its previous obtained outputs. It can be computed easily. The output values can be obtained without a whole lot of calculation, and hashing functions are one-way functions. Basically, you won't be able to determine the input based on the output value. So you can't do the reverse calculation. Now let's go back to our block we were talking about earlier. So as we were discussing, what are the features in the header? The previous hash is the resultant hash of the previous block in the blockchain. And this is the way two blocks are linked together. Now, transaction details, these are used to provide details about the sender, receiver, and how much money they want to exchange between them. And this is a list of transactions, and they are structured in a Merkle tree, and the hash of the Merkle root is put in the header. Nonce is a value that is varied to create a unique hash address of the block, which should be less than the target hash value. So this is the structure of the header. It has a block version number, basically the sequence number of the block. It has the hash of the previous block, the timestamp when the block was mined and verified, the nonce value. The header is then, this entire header is then passed through a hashing algorithm. In the case of a Bitcoin network, it is SHA-256, and a hash value is generated. And now this hash value becomes the hash value of the block. Now this value is a 256-bit value that is used to uniquely identify the particular block. So SHA-256 ensures that alterations to data can be easily detected. So for example, consider these two blocks in the blockchain. They have a similar structure and definitely different hash values. Now if someone alters the transaction details in the first block, the corresponding hash value of the block would change too. Now the values of hash value of the first block and the previous hash value of the other block will not match. Basically, the block subsequent to the hacked block will get delinked. Now this will raise an alarm among the users, informing them that data alteration has taken place. The users will then be able to flag the block, so the alteration can be easily identified and rectified immediately. To ensure security, blockchains also include digital signatures. These ensure that the message comes from the right identity, right person, and that the message is not tampered with. Users are provided their own private and public key. So whenever a user onboard a public blockchain, he is provided a pair of public and private key. Now private key is used by the user to control her own account. This is kept as a secret by the user. So basically it is like his own password. And public key is used to identify the user on the network. This is shared by the user along with the transaction on the network for others to verify. So these are the steps involved in creating and authenticating a digital signature. So at the sender side, the message to be transmitted is passed through the hashing algorithm. In this case of Bitcoin, it is SHA-256, and the hash is generated. Plus, the private key is used to generate a digital signature. Now, this output is passed through a signature algorithm along with the user's private key to create a digital signature. Now, during the transmission, the user's message, their digital fingerprint, which was generated in the previous step, plus the public key are transmitted across the network. So these three things are published on the network for the validators, for the miners to use and verify the authenticity of the sender. Now at the receiver's end, first the message is passed through a hashing algorithm. Now at the same time, the sender's public key and his or her digital signature are passed through a verification algorithm. Now both the functions will generate a hash. If both the hashes are compared and if they match, then the transaction and the identity of the sender is approved. Otherwise, it is rejected. So basically, this is the process by comparing the hash values to authenticate the identity of the sender. Now, what about the people who verify these transactions and how do they actually do it? So remember that one field in the block header called nonce that becomes very important in order to verify the transaction. So now we will talk about the third feature, which is the proof of work consensus algorithm. So proof of work involves people around the world, the participants in the network called miners, competing to be the first one to add a block to the blockchain. And in lieu of this, they will be rewarded. There are competing miners around the world. They are trying to solve a mathematical puzzle to be the first one to be rewarded and to add a block to the blockchain. So this is the reward. So thereby they invest in the computing power, they invest in the resources in order to mine and validate a transaction to get that reward. Now, what is the mathematical puzzle? So basically they need to find a hash value that satisfies certain predefined conditions. Now, in order to find the hash value, they will use nonce. So this target hash value is decided months in advance for every block. The miners keep variating the nonce value to find out an output that falls within the target requirement. So they keep on generating a hash value using the nonce, and if it is less than the target, the hash value is accepted, and if it is greater, then the hash value is rejected. The miner's effort is not considered valid. Now, a miner transmits across the world that he has found a nonce that satisfies the target requirement as soon as he finds it. And thanks to the hashing algorithm used, this claim can be easily verified by others. So basically, the proof of work algorithm, it is very hard to generate the nonce and get the hash value, but it is very easy to verify the transaction by the other miners. So that's a whole lot of work. What a miner's payoff is. So for all his or her hard work, they get paid in the bitcoins. And this is the only way the bitcoins get added to the network. Sometimes they get other forms of remuneration as well. And this is the concept of mining. So the entire process, when the miner has done the proof of work consensus, they are rewarded. And this is called as mining. So mining is the process of adding a block to the blockchain. This miner is the first person who found a nonce value that fell within the target requirement, right? Now for doing this, the miner is rewarded. As of today, on the Bitcoin network, a miner is paid 12.5 Bitcoins for adding a block onto the blockchain. But the reward a miner gets reduced by half every 4 years. So when the fourth year will approach, for the threshold, the Bitcoin reward will go down to 6.25 Bitcoins. And the miners also get the sum of all the transaction fees for that particular block. So the 12.5 Bitcoin reward is justified as mining is a very expensive process. It has a heavy toll on electricity, computing power, and other resources on which the miner has invested. Now we will take a look at the use cases where blockchain is applicable in banks. So we have been incorporating a program where banks can validate user identity. As of now, a user needs to do the process over and over again in each bank. He has to go and prove the identity in each bank. Is there a way we can ease the process with blockchain? And the answer is yes, we can. We will be using Truffle, Ethereum, Ganache, and smart contracts, all of these blockchain technology ecosystem to make it work. and welcome to this demo for how to build your KYC blockchain application. Now I'm gonna show you all the steps required to deploy your KYC application, what all components are to be developed, and how to go about deploying and testing your application. So primarily this KYC application will allow banks to do a decentralized KYC of the customers which come to their banks. So in the demo we will see when a customer walks into the initiating bank, will do the KYC for a customer, enter its details and verify it, and if any subsequent bank wants to use the KYC done by another bank, he or she needs to take the permission of the customer and then he can use the same KYC for verification. So we will see how can we do that. So just to start off with, we have developed a KYC Solidity contract which has all the necessary functions in order to do the actions required for doing a KYC of a particular entity by the bank. Now once this contract is ready, we will be placing it in our sample truffle package. So this is my truffle package, and in this I have the contracts folder. In the contracts folder I have kept my kyc.sol file. Now in the command prompt I will compile my contracts. We can ignore the warnings. So here is my Ganache client which I have just started, and in my Ganache client, as you can see, it is running on port 8545 and it has already given me 10 accounts pre-funded with 100 ether. Now I had already mentioned that my truffle is connected to localhost 8545. So now when I'll do my truffle migrate command, it will connect to my Ganache and deploy my KYC contract. So now I can go to truffle console, and for me it's very important to see at which particular address my Solidity contract has been deployed. I'll copy it, and in my UI code under root.js contract details.js, I will make the change of this address where my contract has now been deployed. Now after doing these steps, my application is ready to interact with my Solidity contract which is being deployed on my local blockchain network. Now as you can see, when I deployed the contract, this is my primary account from which the ethers were deducted in order to deploy the contract. Now there are certain steps in order to get the application up and running. So first we need to sign up the banks. So suppose I say bank 1 and the password should be the first address of the bank. So basically we are associating one bank with one account which we have on our Ethereum network. So we will sign up. Now bank 1 is successfully registered. So now in order to log in, I can check. Now bank 1 I have logged in. Now I need to add a KYC for a particular customer. Now after filling the basic details, I will create the customer, and the username I have kept as customer1. Ideally this is the unique identity of the customer. It can be any social security number or the Aadhaar number or any unique identity which is attached to the customer or the email ID and can be used as the unique identifier for the customer. Now once customer profile is successfully created, we need to log in as a customer to allow this bank to see the KYC details. Now suppose if I say customer 1 and search it, it is saying access denied and take the permission from customer to proceed. So before the bank can do the KYC complete, the customer need to approve it. So I am creating the credentials for the customer. Now customer can see his details, whatever were filled by bank 1, and he can see that there is a request from bank 1 to allow to view his KYC. Now before we allow, I will also create another bank, bank 2, and associate it with my another address and try to log in with it. Now bank 2 is also logged in, Now bank 2 has not done the original KYC, right? But it is trying to look up and its access is also denied. So it needs to explicitly take permission. So the bank will take explicit request from the customer. So now the customer has request from bank 1 and bank 2 for the KYC. It is up to the customer whether he or she wants to allow and deny the KYC request. After the permission has been granted, then only the banks can be able to view the KYC. So if I say bank 1 allow and bank 2 deny, now all the requests are done from the queue. So bank 1 was allowed and bank 2 was denied. So if I again log in with bank 1 and the password is my first address, view KYC customer 1. So here it is, the bank 1 is able to see the details. Now if I log in as bank 2 and give password and try to see it is saying permission denied. So let's ask bank 2 to again request. Now bank 2 is now again requesting and now this time it allows. Now bank 2 can see the details. So all these transactions in the backend are happening on the blockchain network, which is interfacing with the contract through its subsequent methods. Now the primary details of the contract are in the contract details.javascript, where we have to provide the address at which the contract was deployed, the ABI file, the ABI. So you can get the ABI at here. This is the ABI and you can paste it here. And this is the binary data, which has to be pasted over here. So the binary data can be fetched from Remix. This is the binary data for the contract. It has to be copied and pasted over here. Now with these essential inputs provided, our application allows us to interact in a decentralized fashion to access the KYC records of a particular customer. Now we can modify the details also, and we can add a new customer again. So this is a basic demo of how a typical KYC application works in a banking environment. Am I a blockchain expert now? Not quite yet. There's a lot of more information you need to learn. We'll go to that later. Now let's do a quick recap. So what have we learned today? We learned what is blockchain, the Bitcoin story. We understood the public distributed ledger concept, hash encryption, the proof of work consensus algorithm, the concept of mining, and the use case of know your customer, blockchain, decentralized application which is used in banks, and the use case of blockchain in banks. Hello everyone and welcome to this session of blockchain tutorial part 2. My name is Saurabh and I'm part of the Simplilearn team. So let's get started today and let's see what's in store for us. So hey, thanks for coming back to explain how blockchain work. So in our last session, just let's do a quick recap what we have learned. So let's look down the memory lane and discover what we had learned. We learned about what blockchain is. So a blockchain is a list of records which stores data publicly in a chronological order. It applies security using cryptography. It is not controlled by a centralized authority. Any information on a blockchain network is accessible to anyone on the network. And as it is a distributed ledger, it's a shared ledger. Everyone has the copy of the data. So these are the primary attributes of a blockchain. Also, you learned about Bitcoin and how it works. Just to do a quick recap, it was introduced in 2009 by someone or a group of pseudonymous people known as Satoshi Nakamoto. It aimed to solve the problems faced by fiat currencies with the help of blockchain technology. So the objective was to introduce a new asset class of cryptocurrencies which can be used in day-to-day transactions. Now, as of in 2018, there are more than 1600 cryptocurrencies that follow the concept of Bitcoin and blockchain and are very popular in our day-to-day lives. Now, let's talk about the features of blockchain. Is a public distributed ledger. It uses a hashing encryption to encrypt all the information on the blockchain. It uses proof of work consensus algorithm for a consensus mechanism, and it works with the concept of mining in order to reward the miners for keeping them and maintaining the sanity of the network. And finally, about how you can implement blockchain in a banking system. So we talked about how to implement a KYC based blockchain decentralized app and how it allows you to create a decentralized banking system where a KYC done by one bank can be leveraged by another bank, and the customer does not have to go through multiple KYC iterations with each and every bank whom he or she wants to transact with. Now we will get a little deeper into blockchain, and today we will talk about these topics. We will talk about what is a candidate block. We will talk about Byzantine fault tolerance, which was one of the earlier consensus mechanisms. Then we will talk about the problem of if we have to add two blocks at the same time, then how does blockchain handles that? Then we will talk about the concept of forking, what are soft forks, what are hard forks, and other areas where blockchain is getting used, what is the future of blockchain, and what are the upcoming blockchain jobs and the profiles which are upcoming in the market. And then in the end, we will do a quick demo on how to create a smart contract and deploy it for a particular use case. Now, before a block can be mined, a miner has to make a very important decision. Which transactions would be added to his block? So before transactions are added to the blockchain, they are collected in a temporary container called a memory pool. The miners select transactions from this pool and they put it in a temporary block called candidate block. So basically, the candidate block is a temporary block which a miner hopes to add to a blockchain. It's a candidate to be added to a blockchain. So the candidate block holds transactions that the miner selects from the memory pool. The miner then tries to be the first person to find the nonce value that satisfy the hash requirements. Now the question comes, if someone in a blockchain wanted to input the wrong data by spreading wrong information around, would he or she be able to get away with it? And that's why we had something known as Byzantine fault tolerance. So in order to maintain the sanity of the network and to have the correct consensus, there was something called as Byzantine fault tolerance consensus algorithm. To understand this, you need to know what the Byzantine general's problem is. So let's imagine a Byzantine general and three other lieutenants need to take over this town. However, they are at different places and can't directly communicate with each other. So here we have the general and his three lieutenants. The general has to ensure that all lieutenants follow the same order he or she gives them to attack or to retreat. Now, this has to be ensured even if one of the lieutenants is a traitor. So this is the Byzantine general's problem, that how does the general communicates the correct decision which he has taken to all his lieutenants in his network, irrespective if someone is a traitor. In this case, a traitor could ruin the unity of the group by sending different messages to different lieutenants. Now here we can see that general is giving all his lieutenants the command to attack. The traitor could ruin this by sending every other lieutenant the command to retreat, the opposite. Now in this situation, the traitor would make others believe that the general asked them to retreat. So as we can see, the lieutenant in brown is the traitor, and he could communicate to other lieutenants the wrong information and make them act on his behalf as a traitor in themselves. Now this would cause the lieutenants to retreat and the general's attack to fail. So how do we tackle this? The only way an attack or a retreat will be successful is by having a majority supporting that particular action. To achieve this, the lieutenants keep a tally of the orders they receive. So in this scenario, the general sends the attack order to each of his lieutenants. The lieutenants in turn collect the order they receive and pass it on to the lieutenant near to them. So each lieutenant will pass this order to the nearest lieutenant. The traitor also will do the same, but sends the retreat order to the other lieutenants. However, this will not be successful because each lieutenant now has a majority of attack and minority of retreat. So this shows that the majority of the lieutenants would follow the general's command and the attack will be successful. The scenario I mentioned before is Byzantine fault tolerance. Now the same situation can be encountered in blockchain as well. The traitor would add invalid transactions into the blockchain. The traitor would send the inconsistent information to other nodes in a blockchain. This would affect the reliability of blockchain network. Blockchain are able to achieve Byzantine fault tolerance with the help of proof of work. Let's see how it is effective. It is effective because the process of adding a block to a blockchain is a work-intensive process which involves a hashing algorithm. The process is very hard, very computive because it is heavily reliant on value obtained from the existing blockchain. To have any meaningful impact, the hacker would have to take a lot of time, resources, producing sufficient proof of work. Interesting. Imagine if you and I were miners and we both add a block to the blockchain at the same time. How do we handle such a situation? So although this does not happen very often, there is a way to decide whose block should be added to the blockchain. In an ideal scenario, you just need to be the first one to find the hash value. You need to be the first miner to generate that hash value and win the block. So adding two blocks at the same time, the hash value of the block only needs to be within the predetermined limit. If the generated hash value is less than the target, then the value is accepted and the block is added to the blockchain. But if it is greater than the target, then the value is denied and the block is not added to the blockchain. But in this case, if two people have obtained a satisfactory hash value at the same time, so miner 1 and miner 2 were able to find the hash which was less than the target, then what will happen? Whether miners 1 block will get added to the blockchain or miners 2 block will get added to the blockchain. Now 50% of the network has accepted miners 1 block and suppose rest has accepted miners 2 block. So half of the network continues to work considering miners 1 block to be the right block and the other half network continues to work considering miners 2 block to be the right block. However, only one miner's blockchain can be allowed to remain. We cannot have two blockchains running. It will defeat the purpose. Now this is achieved by selecting the subchain to which miners have first added a block. So suppose miner 3 adds a new block to miners 1 blockchain. This block now added by miner 3 is verified by everyone in the network. It is then accepted as the dominant blockchain and is used by everyone else in the network. The other version of the blockchain, the miner 2, is completely discarded and the entire network now accepts miner 1's blockchain and we have now a single blockchain existing. Now this situation is also called an accidental fork. So I heard about a version of Bitcoin called Bitcoin Cash. What's the difference between them? There are other kinds too, like Bitcoin Gold and Bitcoin Private. These are all outcomes of a fork. So what is a fork? A fork is said to have taken place when a blockchain diverges into two potential paths. A fork happens when the users of a network cannot come to an agreement with regards to a network's transaction details and the new rules to validate those transactions. So there are two types of forks which can exist. Either it can be a soft fork or it can be a hard fork. A soft fork occurs when a change in the software protocol makes new blocks added to the blockchain following the new rules but are backward compatible. But in order to have a soft fork, it requires a majority of the users to commit to that change to be successful. So a soft fork could have multiple uses. It could be for tighter rules, it could be for cosmetic changes, addition of new functions, but not affecting the structure. So consider the scenario where the accepted block size is to be reduced from 1 MB to 100 KB. So first of all, it has to be approved by a majority of the network. Now, the old version will be running on 1 MB block size, but once approved, the new version will start working on a block size of 100 KB. So anything which is less than 100 KB will be approved and will be added to the new block. So over time, people following the older version of the blockchain would be forced to move to the new one since none of their transactions would go through. So basically, people using the old blockchain, they will be using the 1 MB block size, their transactions will not succeed and they will be forced to use the 100 KB block. Now let's talk about hard fork. A hard fork involves a change in the software protocol so radical that it forces a new blockchain to be created altogether. So basically, in a hard fork, there will be two versions. There will be one blockchain that hasn't upgraded and there will be a blockchain that has upgraded according to the new software protocols. Both these blockchains will be considered valid and legitimate. The new path would follow new updated rules while the other one keeps following the old path. So the old one will not be discarded and will remain into existence. Now, Bitcoin performed a hard fork on 1st August 2017, which created Bitcoin Cash. So thereby both Bitcoin and Bitcoin Cash remain existent. Now, Bitcoin Cash was different from regular Bitcoin because it increased the block size from 1 MB to 8 MB. So thereby it helped reducing the transaction cost significantly lesser than that of the original Bitcoin network. Now, other than with Bitcoin, where else is blockchain used? The other areas are for preventing voter fraud. Blockchain helps in ensuring that there is only one vote per person, ensuring that the data is not being tampered with or any false alterations are done. It helps creating an immutable ledger to record the votes as tallied. So once a transaction or a vote is recorded, it cannot be modified. It is also used in quality assurance, ensuring the products are of highest quality, being able to identify problem areas easily. So where do you think blockchain is going to be used in the future? So blockchain is seeing wide range of adoption amongst organizations. As of now, only 1% of all organizations have begun using blockchain technologies, but this percentage is expected to increase in the next 5 years or so. Then there is a need for blockchain regulations. The rules and regulations surrounding blockchain are not very clear for organizations to be comfortable using it and move towards faster adoption. Also, there is a need for removing the negative speculations surrounding blockchain. Several industries fear that blockchain will disrupt their normal functioning and believe that the adoption of a blockchain system isn't worth the effort. And there is an increase in job opportunities for skilled personnel. So as the technology is maturing, there would be a huge requirement for individuals who can understand and implement the concepts of blockchain. So what options do people have for jobs involving blockchain at the moment? There are many job opportunities, but the two most famous ones are blockchain architect and blockchain developer. Blockchain developer is a profile which requires designing, implementing, and supporting a distributed blockchain network, analyze user requirements, design technology around a certain business model to build and launch a blockchain network. Blockchain architect profile requires to design and architect blockchain industry solutions, creates blockchain networks leveraging blockchain technology platforms, produce high quality code based on project requirements, conceptualize, design and build blockchain frameworks and assets. So let's have a quick demo on how to deploy a rating smart contract and have decentralized application running on a local blockchain network. We will be using Truffle and Solidity to build this application. So in order to build this application, we should have installed Truffle and Ganache on our local system. So this is a Ganache client which is running on my local host. It is running on port 8545 and network ID 5778. Whenever you run a Ganache client, it is preceded with 10 accounts and 100 Ether balance. Now, this is my movie rating app, and in this app, I'm going to deploy a smart contract called rating.sol, which is going to capture the ratings for a certain set of movies which I'll predefine, and the users will be able to set the ratings on a blockchain network in a decentralized fashion, and we will be able to see that in every transaction a block is getting generated in my Ganesh client. So in my movie rating app, under the rating folder, I will run the command truff compile, and it will compile my smart contract rating.sol. Now the next command which I have to run is truff migrate. Now at this instance, the truff migrate command will deploy my smart contract on my Ganesh client. So if you see, there are 4 blocks which have been created, and my contract was created in this transaction, and this is the address of the contract at which my contract is deployed. So I can go back to my command prompt and say truff console and check the address of my contract. So this is 0x695, which is this address. Now when I deployed my smart contract, I had given the entry of deployment in a file called deploycontract.js under rating migrations, and in that I had given this entry. I had given the path to my rating Solidity file, and I had initialized my smart contract with 3 movies, Star Wars, Avatar and Inception, and given some predefined gas. Now once these steps are done and I know the address at which my contract is deployed, I will copy that and paste it in the file of Ethereum setup.js, which is lying under my rating app UI source folder, and I'll just change this address. Now once this rating address is changed, I have to go back to my movie rating app folder. Under app UI, I have to give the command npm start. Now my application is up and running on localhost 3000, and as you see, I'm able to do the voting, and at each rating level my block is going to increase. Block 6, Inception, block 7, and as and when my rating is increasing, a block is getting added. So this demonstrates the usage of Truffle and Ganesh in order to build your decentralized app. Wow, blockchain is amazing. Thanks for explaining these things to me. I'm glad I could help you.
How do you become a blockchain developer? And it's one of the most frequently asked questions that I have encountered as well from most of the people coming from different backgrounds. It's not only from only technical, for only people from coming from technical side, but also someone from a very different industry, and they are quite interested in joining the blockchain domain in terms of how they can build something that can change the whole game of how we do the transactions and these things. So we are going to discuss a little bit about what could be the kind of steps or what could be the ways that you can be a blockchain developer. And before going into the discussion of what are the ways for that, first we must need to understand who is a blockchain developer itself, because there are quite different terms that being used. Like some of you maybe have heard about smart contract engineer or blockchain engineer or blockchain developer. So these are different terms that's being used interchangeably. So along with it, you must need to know the main understanding and the terms that being used and what is the meaning of being a blockchain developer. So moving forward, we are going to discuss a kind of what could be a type of blockchain developers, on which side you can focus, and then you are going to explore some of the steps that how you can become and how you can be planning your journey to become a blockchain developer as your career. So we'll be moving forward in terms of also just exploring a little bit about the market. There was the salary range that's being provided and a kind of, you can say, obstacles that is for someone who wants to learn blockchain development or who wants to learn this technology. So this is a kind of our whole agenda that what we will be discussing in our today's session. So first of all, let me first move forward with the kind of questions that who is a blockchain developer. So initially, what I would say, whenever you want to achieve something or whenever you plan to get yourself into as a part of your career, as a part of your next role, first of all, you should understand some of the questions and you should ask yourself a few questions. who, what, and why you want to be to be that position. So that's very important. First of all, you do try to understand who you want to be, like who is a blockchain developer, who is a kind of position that you are looking for. Then what are the ways to become that specific professional in the market, and then why also you should know that why you are looking forward to be yourself, be a part of this industry or be a part of this domain. That's quite very important questions that you should ask yourself, not going to answer anyone, but ask yourself and satisfy yourself with these answers. The reason is that that is going to compose your whole goal or whole motivation for your whole career journey. In the terms, let's say if you know that why you are planning to be a blockchain developer, what is your reason to be in this industry, what is your main motivation, you will be stayed on the whole track and you can plan these things in a real way, or you can say in a kind of, you will have some timeline that you wanted to achieve, that you wanted to be in this domain. So make sure that you do ask these three questions before getting into any XYZ technology. It's not just related to blockchain. It's a general kind of three questions that I usually make sure that I am clear enough why I'm going into this direction. So that's just my personal opinion, or a kind of my personal belief that I should know that, okay, why I wanted to be there and what could be the ways and who I am going to be. So as a part of this whole series, we are first going to explore the questions, that is, who is a blockchain developer? So starting from, if you are just discussing about a blockchain developer, it is presumed for sure that you are well versed with the technology itself, or with the working of this technology, why it exists, why it came into the picture, what is this buzzword everywhere, and why this is booming a lot. So as a whole, it's being assumed that you should know what is the blockchain technology. So if you talk about the technology itself, the core functionality, or you can say the core features of it, you are well aware of it. So implementing and designing that whole blockchain network is something that a blockchain developer do as well, like how you design a whole network, how you implement and support a network also, and then coming towards creates and optimizes blockchain protocols. And the very last thing that you go with is how you develop dApps and smart contract applications on the blockchain network. It's very important to understand those terms. If we talk about the dApps, dApp is a kind of like distributed applications that we use these terms quite often when it comes to blockchain developer. You may have heard from someone like, okay, I'm looking for a dApp developer, someone who can develop a dApp for me. It's something like we are talking about applications that needs to be developed on the top of blockchain technology, and it could be any blockchain, like public or private, any blockchain. So that is very important. If you understand these kind of acronyms and you really know the meanings of these acronyms, that's also very that's something that matters a lot. So dApps is something that you are going to have those applications built on top of blockchain, and that's one of the part that blockchain developer do also. And then come towards the next part, that how do you develop these dApps using like writing some smart contracts using any programming languages that we'll be exploring in the few slides afterwards. So coming towards like how you write a smart contracts, what are those kind of programming languages that is needed for you to know and to be well versed with this, so you know the how you are going to make it technically feasible for your whole career and to get your next role. So coming towards what could be the type of blockchain developer you can be, because what we discuss is a quite a lot of different things. If you notice, the very first part that I mentioned was that how you can like designing the network, implementing and architecturing the solution. That's one part of it. Then we talked about another aspect of how you can like security and optimizing the whole app development, and then writing the smart contracts and developing the applications itself. So if you focus on the sides, it's being divided into two sections. One is a core blockchain developer who actually works into the underlying blockchain architecture, or you can say working on the consensus algorithm, that how these things going to be working. So that comes under the core blockchain developer. And then another part that's important is the blockchain software development, or you can say DApp developer, who is going to develop the application that's being used or that's being built on top of that blockchain technology. So if we talk about the whole blockchain development cycle, or you can say the layers, is you have one blockchain hosted on which you are going to develop your blockchain application. So first, you should be clear enough what kind of blockchain that you are going to adopt. It could be a public blockchain, it could be a private blockchain, or maybe a kind of hybrid somewhere, consortium or hybrid blockchain. And then coming towards finding the right talent for the type of blockchain that you are working on. Then that's the next part of where software developers, or where you can say developers in general, lies into. That's the next part of blockchain developers, that how you're going to write those smart contracts or kind of chain codes, and how you're going to make those applications work on top of blockchain. So when we talk about first thing, that is core blockchain developer, they are the one who are going to work on the core features of the blockchain network itself. So if you focus on the category of the blockchain that you will be selecting, let's say if you are going to go for the public blockchain, for Ethereum or kind of any application that you wanted to host on public blockchain, so that's a kind of different thing. You know your consensus, you know everything that's already running into the network. But when it comes to a private or enterprise-based blockchain, you have a quite different architecture. It's quite bulky, it's quite vast. Like, you have to work around what kind of network you wanted to build into, how many organizations will going to participate into the network, what will be the consensus mechanisms that will be used, then how you're going to set up, like, let's say if you're talking about hyperledger fabric, you have to architect the whole thing, like participation of endorsing nodes and CAs, and let's say how its whole MSP is going to work, and then the consensus mechanism, and how it is going to be committed to the ledger after going through this whole endorsement policy. So there is quite a lot of network part that needs to be done in terms of private or enterprise-based blockchain, which is not that much required when it comes to any public blockchain. So the core blockchain developer are the one who is responsible for working on those side of how these network is going to be built into. So if you just explore a little bit about Hyperledger Fabric network administration, that's something, a separate role that's being required for the organizations who develop on top of Hyperledger Fabric. It's not that they expect the programmers to do the whole networking and whole architecting at the base layer, but they expect the network part is something that they expect someone else who have the required expertise in that aspect. So that where is the core blockchain developer come into, like when you talk about the architecture or working on this consensus algorithm and how you're going to set up the whole blockchain network. That is one part of the blockchain developer that you can be. Now, the next part, that when it comes to software development side, this is where the programming comes, like how you are going to develop your application that is going to work on the top of that specific blockchain. Let's say if I decided that I wanted to build an application that is going to be hosted onto a public blockchain. So it's a public blockchain application. So I want a dApp for that. Like, I want to build an application. So definitely you don't need to work onto that underlying core blockchain layer, setting up the network and these kind of stuff. What we usually do is that we directly go towards writing our smart contract logic. Once we understand the whole architecture, whole flow of our solution, that okay, what kind of smart contracts we are needed, at what stage we are needing that smart contracts, and what is the whole flow of information from one end to another end, and who are the participating entities and all these stuff. Once you have a very clear idea of that, you go into developing those applications in terms of writing your core code, core program into the core programming side. Then it comes to writing your smart contracts, and first you're going to use a test network, let's say. So you're going to host it on a kind of like test network for Ethereum, or then you are going to move into a mainnet. So that's a kind of things that's mostly on the side of blockchain developer, that how you are going to write your code, compile it, and deploy it itself onto the blockchain network. So coming towards that, what kind of responsibilities and the usual and the major responsibilities that needs to be covered by a blockchain software developer is smart contracts, writing the smart contracts, or you are required to develop the whole distributed applications. So the reason of mentioning this develops the distributed application is that just writing the smart contracts is not something you do only. You should know that about what will happen when you are going to deploy your network, and how you're going to check up all these gas fees and a lot of stuff that happen there once you deploy your smart contract onto the blockchain network. So that's where this blockchain software development come into, and then the last part of it, that how you work on this front and back end application. So we have a kind of some middleware APIs on which we work. Let's say if we are talking about specifically Ethereum-based development, we use a web3.js to interact with our smart contract and to talk to our front end also. So that is the library that you are expected to write the code and know that how you are going to interact with these two layers and act as a middleware, and how you're going to write that specific kind of HTML code which will link to your smart contracts easily. And the same thing that follows if you're talking about any other blockchain, let's say in terms of private blockchain. So in Hyperledger Fabric, when we are developing an application, for that middle layer specifically, we have different kind of SDKs that we use. That's being provided, let's say, by a Fabric SDK. So you are bound to be use like kind of Java SDK or Node SDK or any kind of new SDKs that being provided to them. Let's say Python is in line as well with them. So these are a lot of things that's also involved, that how your middleware will work to talk to a front end for your blockchain based application. That also comes under the blockchain development or kind of how you're going to work as a software developer or the core technical team for your blockchain development side. So coming towards that, how do you become a blockchain developer? Now, that's not a question that I am going to give you rigid answers on that, and that's something that you should follow. But I believe that, as I started in the earlier part of our video, that you should know answers of these questions by yourself. How you're going to do that, or what you want it to be, and who you want it to be, and what are the ways to be at this stage. So when it comes to how do you become a blockchain developer, so there are a few things that's being mentioned here. It's a few things I'm mentioning because it could be more than that. It definitely depends on the type of role that you are looking into, or on the type of organization that you are planning to like join in, or targeting to be the next employer for them. So it's quite you can say quite varied options that how do you become a blockchain developer. But that's one of the, you can say, core answers that's everywhere if you found the ways of being a blockchain developer. So the very first part that's very important is the programming language, because as we discussed, the part of being a software developer is that you should know a kind of programming language of writing the code into the blockchain, into this blockchain whole network. So some of the programming languages that's being mentioned here, it's like Java, C++, JavaScript, Go, Python, and C#. So as a whole, I would say that is very important for being a blockchain developer is you should be well versed about the basic programming paradigms and how a whole object-oriented programming work, like the base pillars of object-oriented programming. The reason is that's something quite similar when it comes to those programming languages. So if you talk about any of those programming languages, it's not something that you are expected to know all of them. Definitely, no one is not expert in all of these programming language. But if you are well versed with any one of them, or let's say any two of them, you are expected to write your code or understand the main you can say main rules of writing any programming language, because you are already well versed with any one of or any two of them. That's very important part, that this is the core of a programming language that you should know. Now, how it works into writing a blockchain based development, it's something that you are going to learn when it comes to any kind of blockchain development course or any kind of session that you will be joining. So that's something that you will be learning as an advanced aspect of it. But the base, if you know, you are that's going to help you a lot in terms of your next journey for the blockchain development. So coming towards the side of writing programming language or the side of software development on top of any blockchain application, there is also one programming language that started with the smart contracts, or with the existence of Ethereum. It's Solidity. So Solidity developers are something that they are exclusively expert in writing this Solidity code or Solidity smart contracts. That is being said because Solidity itself is a contract-oriented language, okay? But if you just get yourself into, or if you just go through a little bit of how it works, or a journal view of it, you will notice a lot of things that is very common and a lot of concepts that is very related to object-oriented programming. Like if you talk about how you create a class in object-oriented programming language. So that is the same thing that we follow, like how you create a contract in object or in Solidity itself. Then we have few of the concepts that's very much similar to it. We have inheritance in contracts. We have abstract classes, interfaces. Then we have a kind of aspect that how you encapsulate things, like the encapsulation aspect of it. So a lot of things, how you use a constructor also. So there are a lot of common things that is very much similar to what we already know in object-oriented programming language. So for those of you who are a kind of confident or kind of comfortable with any of the programming language that we just discussed, you will be able to understand Solidity very much easily. One of the different thing that you will find in Solidity is that how you are going to play around with a kind of wallets, with a kind of addresses, how it is maintaining connecting to a wallet or maintaining an address, like say smart contract address itself, and then how it's going to hold some ethers. So there are a lot of things, or some of the terms or keywords that is different when it comes to Solidity. And obviously it is expected to be, because that is something that makes it unique. So these are the things that is different when it comes to Solidity based programming language. So if you are comfortable enough in writing Solidity based code, or you can say you are well versed with any of the programming languages that is in OOP, that's object oriented programming, you will ace the Solidity side very easily. So you can start understanding the concepts and writing those contracts in kind of Remix IDE, that is a browser-based tool. You don't need to install anything, and you can just start compiling and trying out your first smart contract very easily by just installing a kind of like MetaMask wallet or something. So that is the very core part of blockchain development side. First is the programming language, and then the very next part that I told you already, that is fundamentals of object-oriented programming language. So we know that how this is related to a blockchain-based development, that how you write a kind of functions, how you get the details for your users, and how you use some functions to send and receive payments, and let's say how you create abstract contract, or there's a kind of how you write some interfaces for your contract. So some very of the concepts that we already know in object-oriented programming language, it's quite, you can say, similar to what we have in Solidity. Then we have a kind of flat and relational databases, or you can say that to understand the main concept that how that RDBMS work or the flat databases work in terms of, if you know this kind of file storage or data storage, you will be easily understanding that how we are talking about the importance of blockchain technology itself, and how important this technology itself. The reason is that if you talk about blockchain based technology as a whole, it's just a kind of data structure, or you could say a technology which works on storing of data, that how do you store data, and then the architecture or the flow of storing the data, that is how it makes it different, that how you're going to store it. Like either it's in a distributed network, either it's in a kind of you have a ledger that is decentralized, there is no central authority. So these are some of the things, if you understand the main concept of flat or relational database, you will be easily understanding these kind of things about data structures and how it's being storing this data in terms of blockchain, and how it is unique to any other databases or any other data structures also. So one of the major things also that's written here is that you have to have some understanding about data structures, like let's say stacks, linked list, queues. So these are some of the data structures that we have. So if you understand some of them, that's very important, that it is linked to blockchain in the way that blockchain itself is also a chain of blocks that is linked together. Like it's a kind of linked list, and every block is containing the hash of previous block. So it is chained together. So kind of it is linked together. So it works in the same way that we have linked list. So that's one of the reason, if you understand those data structures, the way how blockchain works at its core of a data structure, it's going to be very easy for you, and you will be able to understand that how this works in a kind of data structure perspective. And then about some of the knowledge of web app development. So that's a very common thing that when you talk about any kind of development side, so if you know that how web and mobile application works and how you create these applications, and apart from it, because the concepts that, let's say if you create a mobile applications and you want to expose some APIs to get data onto a mobile application, that's something very much same that we do in blockchain development also. So these are some of the concepts that you are being expected to know when it comes to becoming a blockchain development. So the very last part of this this points that how do you become a blockchain developer is the peer-to-peer networking. That's something that I already mentioned in the type of how you understand the core concept of blockchain technology in terms of storing the data. And then it comes to the networking side, it's really important. Like let's say those of you who are coming from, let's say, a very old and very basics of computer science, you must have heard about client-server architecture. So what client-server architecture do? We have a server to which all the clients report to. For any of the requests, for any of the things, whatever being accepted or whatever being provided by the server, those clients receive and work on it, and they will be able to perform next steps on it. So client-server architecture is something that is centralized, like we don't have any relation with one client to another client, but all of those clients are linked to one server, or let's say more than one server, but those servers are the one who is controlling and who are the managing authority. But when it comes to a blockchain-based system, we don't have that aspect of centralization. It is a core decentralized network that's being also said as peer-to-peer networking. Why? Because all the peers talk to each other and can see the transactions, whatever others are seeing also. So that's the core part of blockchain development side. If you understand those terms, if you understand that how these things work, that is one of the major thing. And then we talk about some of the acronyms that's very important. Like let's say that is P2P. And one of the things that I mentioned earlier is dApps related to distributed applications. That's also very important. And very last, third acronym that I wanted to mention is DLT. So what is DLT? DLT is distributed ledger technology. So if you talk about a blockchain-based technology, or you are trying to understand this technology as a whole, you are expected to know that, okay, what is DLT itself? Because it is a very important question. Most of those who are just newly entered into this field, they know the core, they know the very advanced level of blockchain, but they are not well versed with this term that's said as DLT. It is a very important term. If you just focus on this term, it's an umbrella term. Like, we have a lot of different technologies under DLT, and one of them is blockchain technology. So blockchain is a DLT, okay, but we have other technologies that comes under DLT as well. Let's say we have hash graph, we have directed acyclic graph, that is DAG. Then we have, let's say we have another technologies that we work into. We have Hedera hash graph and blockchain, and many of those technologies that comes under DLT. It's very important to understand that the core of DLT is the ledger is distributed. Like, it's going to work in a decentralized way, in a peer-to-peer manner. But how it's going to store the data, like the storage of the data, it's different. Not all of those technologies store the data in blocks. So it's not all DLTs are blockchain, but at its core, the blockchain is a DLT itself. So that's a very broad and umbrella term that you should know as being a potential blockchain developer. Make sure that you are clear enough about these terms and you are well versed about where and why you are using these terms. So these are some of the prerequisites that we discuss, that okay, how you want it to be, how you do becoming a blockchain developer, what is a blockchain developer itself. I believe at this stage of this session, you are clear enough about two of this. What you want it to be, like who is a blockchain developer? So who is what you want it to be, like what could be your next role, and then how do you become a blockchain developer? So these are, as a whole, is just a core steps, and then you can extend your research, you can extend your plan and make your you can say whole journey, that how you wanted to reach a specific goal in terms of becoming a blockchain developer and getting yourself into this whole ecosystem. So let's move into the very next step, that says the very first step. If we have got all our prerequisites, that's clear, we know what we want it to be, we know how we are going to be at this stage. So the very first step, if you notice of this whole system, is the first thing that you understand the basics of blockchain. So to whoever usually asks me this question, I would say that as a whole, that's very important to you to understand and to go backwards to the point where this technology started. So for the blockchain, if we talk about the very first white paper, or you can say one of the white paper that started gaining the traction for this blockchain-based technology is Bitcoin. So what you do, you go towards this Bitcoin white paper and try to read it and try to grasp the whole concept, what's being written and why it came to in existence, and how this technology played an important role in the whole in this whole system that's being proposed in that white paper. And that stage, I wouldn't expect you to be a master of blockchain technology and even to be clear of all the terms that's written there. But after reading that specific white paper, you should be just clear enough what is this technology, what is the potential of this technology, and either I am interested or not. Like, let's say either I am convinced with what this technology has done to this whole payments ecosystem and everything. So if you are a little bit clear enough at this side, you are very good to proceed further. And then what you do, you proceed further with about understanding the core terms or core concept of blockchain technology. Let's say we have different types of blockchains: public blockchain, private blockchain, then we have hybrid blockchain. So coming towards understanding the terms, if you understand the base term of blockchain, then you move forward with, let's say, public blockchain, that is Bitcoin. And after going towards Bitcoin, you go and check in the history, the next step and the next revolution came into the terms of Ethereum, how Ethereum came into, what was the reason for that, and how it changed the whole game of this blockchain ecosystem. So there you are going to explore a lot of things in terms of this blockchain based technology. The reason of that is that with Ethereum ecosystem, we had a lot of things that came into the picture which was not there earlier. We got the way that how you can automate your business process in terms of those smart contracts. And then using that smart contracts, the scope of this blockchain technology extended, and it is being explored that you can use this technology out of this payment ecosystem or out of this financial services. We have a lot of, you can say, potential of using it in different ways, or you can say in different use cases. So there come the potential and the power of this technology. And if you explore a little bit of the whole journey of Ethereum, you are going to find a lot of things that's very interesting. The tokenization aspect of it, the mining process, that how it changed up to the latest trend that we have in now in 2022. So that's very important part of the whole journey of learning these core of this blockchain based technology. And then coming towards the base, let's say hash, that how this cryptographic hash is used, how the system is secured, what's the kind of encryption that's being used. So you can go through and play around with some of the, you can say, demos and illustrations that's been provided using that how your data is encrypted, how you cannot change a block and it will break the chain. So a lot of things that you can explore in at this step. And you know, okay, there is some mining that's being provided, some consensus that's happening, and the reason of that consensus also. And the next part of knowing, after knowing those kind of terms, is that how you explore these things, let's say Ethereum, Hyperledger, Hashgraph, or Corda, R3 Corda, that's very important as well, and other solutions that is built on top of layer 1 solutions. That's, let's say we have a lot of layer 2 solutions into the market now. But that's another very extended form of blockchain. So as a base, what we do is that you explore, starting with Bitcoin white paper, then you move toward Ethereum based blockchain, and then you go and explore a little bit of Hyperledger Fabric. And if you are at the stage of understanding Hyperledger Fabric, you can look up into the R3 Corda as well. So a lot of things you are going to explore in this whole journey, and you will going to understand the basics of this blockchain itself. So if you talk about this whole steps that we have in this whole system, in this whole systematic way, it is started from prerequisite. If you are done with prerequisites, we are now moved towards step 1 that we have already done, that says the concepts of blockchain. And the very next stage is that you understand the economics behind cryptocurrencies and blockchain-based technology. So that's the part that is very important. You understand the whole economics in the term of the usage of blockchain technologies in crypto world, and a lot of it on the side of how it works in terms of issuing some kind of tokens, and then we have token standards, how you write these tokens, and the important and the and you can say how it the prices, how you're going to increase your price for tokens. And then we have the next era that we know that right now we just passed is this NFTs, that how NFTs came into the market and what is the best use case of it. So a lot of things you are going to explore in terms of security, that says hashing, that says the kind of hashing algorithm that's being used, and the digital signatures, knowing that how this works as a core, and then the consensus mechanism also. Let's say proof of work, proof of stake, why it's being used, or why there is some transaction that being happened from proof of work to proof of stake. Knowing the benefits and disadvantages for each of them, it's very important also. So that's one of the things that needed to be on the side of, you can say, more into the side of security or more into the side of technical aspect of blockchain. The other part is that the economic side. On the economic side, we have the understanding that the miners, or you can say the validators who validate the transaction, are being incentivized. So it is very important for you to understand that how you are going to be like, is there some calculation that's being happening? It's something, some halving is done, and after that, what's going to happen if it's finished, the block rewards is finished, or what's going to be happen with Bitcoin? So that's some of the questions that if you explore, that's going to have some, you can say, some interesting facts that you are going to explore in this whole journey. Along with it, it's very important that you try to understand about private blockchain also. If you are exploring it, try to go into as a whole, not just go through towards public blockchain and you don't know the difference between private and public. So if you're talking about private blockchain, you should try to explore a little bit what happens with the validators who validate the transaction in a private blockchain. So who is being rewarded, what kind of reward is being given. So you can read out some of the use cases or some of the success stories and case studies that's been published to, let's say, onto the official website of Hyperledger Fabric or Linux Foundation, or official website of Ethereum Foundation itself. So a lot of things that you are going to find out on their own official website. And for further, you can say, latest up-to-date trends and happenings into the industry, you can watch out to some of the videos, let's say, and videos in terms that what's being happening and what's being announced by their like say co-founders, founders, or any of the speakers who participated into the conference, because that's also very one of the interesting part of the conferences. If you join that, or if you follow some of the blockchain latest conferences, some of the very biggest, you can say, announcements or biggest change that's been happening into the ecosystem, they announce usually there into the conferences also. So you can follow up to the conference to understand and to, you can say, follow the trends, what's happening into the industry as well. So the very next step, that is how to understand how cryptocurrencies work. That is also very important. The reason is that when it comes to the blockchain-based ecosystem, it started with the very first use case is the financial use case, is how you can eliminate a middleman and do some transaction peer-to-peer. Let's say Alice and Bob, they don't need anyone in between and they can do the transactions without any one of them. So that's very much important to know that if we are removing the middleman, who is going to do our transaction then? Definitely, we do have at the core, we have this blockchain based system, let's say Bitcoin, who is going to do this transaction for us. And if you just go backward in terms of the middleman, we are going to have some validator or miner who's going to mine our transaction. But a lot of things that are changed when it comes to peer-to-peer transaction, when it compared to the traditional and current banking system or financial system that we have. So that's very important to understand how this cryptocurrency system works. If you send the money from one account to another account, let's say in terms of ethers, or not only in ethers, if you are trying to do some transactions and you are having, let's say, some tokens or something, then you will be able to do this transaction very quickly, and you will be able to understand it very quickly, how this thing is very different to the traditional system that we have. So that is also one of the very important step of this 4 steps or 5 steps journey. So you start with the concepts of blockchain based technology, and then you understand the economics behind it, in which you explore the kind of like security aspect of it, the cryptographic algorithms that's being used, and who will be rewarded and how the reward will be done, and then how you understand that how these cryptocurrencies work, and the last thing is that you're getting on some hands-on experience. And then when it comes to now at this stage, at the 4th stage, I believe you have a clear idea about the technology. You know the strong use case of this whole technology so far that we have. You are well versed with the technical terms that is being used in this whole, you can say, in this whole technology, or what kind of consensus or encryption or encryption algorithms or mining, why it's being happening, and the whole flow. Okay. And if you are clear enough at this stage, you are now able to getting yourself onto some hands-on or onto some coding aspect of it. So for this kind of writing some programming and some smart contract, you are now able to start your journey as a blockchain developer. So this stage is very important for a kind of how you are going to select what kind of programming languages that you want to be, like what kind of blockchain development you want to be. Let's say it's private blockchain, public blockchain, and then you will decide that, okay, I want to write a smart contract, or I want to write a chain code in Hyperledger Fabric. That's also the choice that you made initially. And then you write your smart contract, and you know that, okay, if let's say you are writing it on Ethereum based blockchain, you are going to publish it on Ethereum based network. So let's say in terms of test network or in terms of mainnet, you can publish it on the Ethereum based blockchain. And then let's say one of the major thing that's written into the whole journey, what I appreciate, it's not that you do the work from your end and you expect the things to happen like magically from the employer end or from the end of hiring you. What is the best way is that if you make something, if you have coded something, even it's a very small application, try to show off to it to others that what you have made. By showing off means that you can convince other that you have the right talent that is required for this specific programming language. It could be in any way, like it could be like either you go for having your own GitHub profile, maintain your own GitHub whole GitHub portfolio that you can provide to others. So that's a kind of all your programs they're written, you have all your files that you can provide to others, just to know that, okay, what kind of smart contracts that you can write. But also you can write some articles out of it. Let's say if you are writing a code in Solidity programming language and you came up with an issue of how you're going to, like, you explored some different ways of error handling. Like you have different functions in Solidity, right, for error handling. And from your own experience, you find out some amazing way of doing error handling in Solidity that saves some gas fees, and you believe that's a better solution out of what you have been already being provided over the internet. What you can do, you can write a complete whole article on it on the basis of, okay, this is my personal finding in my whole journey. I found out this is the best way, and I encountered these issues, and to resolve this kind of problems, I tried fixing it in this way. I wrote this code, and that's how it worked. So what will happen? Others will know your problem solving skills, your skills of writing a good and solid smart contract. That's very important. So never underestimate the line of code that you have written or the application that you have created. It might be very small for you, it might be something that's not convincing for you, but for other, or let's say to others that who are looking up to as a candidate for you, as a candidate to you, maybe it's going to be something that's very big for them. So try posting whatever you have learned, whatever you have made. You can also do some participation in hackathons. Let's say you can participate and team up with others and create some very, you can say, convincing and solid application in a hackathon. That's also going to add on a lot in your portfolio, and that's also it's very valuable when it comes to being this whole blockchain development journey. So it's not something that I would say only in blockchain development journey, but for any of the development side, it's very important that until you create something, you are not going to learn it in that way. So try getting your hands dirty as early as you can. And then once you are at this stage that you created a solid application, you can just go and post it somewhere and create and maintain your own portfolio so that you will be able to portray to others what you have made. Okay. And then that is very important again. I would say the whole blockchain ecosystem or this whole blockchain based technology, it's evolving very fast. So the developments or the happenings in this industry, it's very quick that you don't know that when what will happen. So the very important part is that you keep yourself updated with whatever being happening. It's not about just keeping yourself updated, let's say who adopted Hyperledger Fabric for their problem, or which bank adopted R3 Corda and they are working on a solution with partnering with, let's say, Swift is now working with blockchain-based technology. It's just the high level that you should know. But at the core, you should be knowing what's happening inside of this blockchain industry itself. One of the very common and latest trending news that we had in the past few weeks is the merge that happened in Ethereum from proof of work to proof of stake, and how they merged this whole layers in the Ethereum ecosystem. So the reason of understanding and keeping an eye and keeping yourself updated is that this technology is evolving very fast, and even the solutions and the startups that's being built into it, it's quite you can say quite quick. You cannot expect anything to happen maybe into the next few weeks, but there is some very amazing happenings or amazing startups that's being built upon on top of, let's say, any financial ecosystem or for any industry. So try to keep yourself updated, and how you do that, so it's up to you. You can follow some of the latest trending articles that's publishing some news on blockchain, or you can also just find out some of the solid connections on LinkedIn and get connected with them, follow them on Twitter, so that you know the latest news, what's happening there. And that's one of the reasons that's important that you visit and write some articles, visit the blogs as well, and be a part of this ecosystem. Always make sure to put your input, to add your input wherever you feel you can. Let's say if today, after today, you know that, okay, I wanted to be a blockchain developer, and you are looking for some of the articles, and you have a quick thought that, okay, no, this is how it should be. No, I believe that this ecosystem is like growing, so scalability is something that's very important or something. You can put whatever you know and whatever your thoughts into a comment. Don't ever feel shy, because that's how you are becoming to a part of this whole ecosystem. Now, the very important part is what we will be discussing next, because how you become a blockchain developer, we discussed it. And then comes to what kind of obstacles do you face when it comes to learning blockchain-based technology. So coming towards the part is that how difficult or easy this programming language is, something that related to what kind of issues you face. Okay. So first of all, that's very common, and I believe it's most of us face this issue, that the outdated content. Let's say if you are working on Solidity based programming language, and if you are reading and following an article, but it was written for a very old version of Solidity compiler version, but you have followed the whole exact program and your program is not working on that latest version because maybe something has changed and they've made it work in another way for the latest version. So this is very important. The content that you are following must be latest. It's not a very old content that you are following, or it's not something that you can say already outdated. Okay, so that's very one of the obstacles that we would say into the Solidity or into the blockchain based journey is that the tutorials you follow or the content that's being written there, maybe the issue is being resolved already, but you are following some content, some tutorial that's very old. And one of the second aspect is very common again is the lack of quality content. Okay, so the major thing is that most of the places where you will see that, okay, you will be a blockchain developer in 6 weeks, in 2 weeks, you will be a smart in 4 hours videos. So a lot of videos that you will be able to see that. It's not that they will not give you the right content, they will definitely give you. But the quality content is very important. And also, after getting this content, what you do afterwards is also very important. So the investment from your side as a learner or as a potential developer in this field is still there. Don't just expect things to happen in a magic way once you follow a tutorial and you believe that, okay, I created this application, now I am a master and I look forward to the opportunities and I believe I will be getting hired somewhere. Hopefully you will be, definitely, but how you can make your place in the industry is that you try to create something and then make some updations on it. Let's say now we have a lot of layer 2 solutions also. So try to explore many of those solutions or many of those you can say some of the SDKs that's into the system, or some of the tools that's now just came into in this whole blockchain based development side. So that's also very important for you to learn from a quality content, not from old content. Now that's another very you can say one of the very attractive part of blockchain based development is the salary of a blockchain developer. So coming towards the average how much a blockchain developer earns is something around if we talk about in USD, it's different definitely. So it starts from 100K per annum. Okay, it's just a starting. I wouldn't say it's an average, but it's more of a start. But it definitely depends upon the size of company that where you are looking for and where you are aiming to. Let's say for a startup, it's going to be a different, or a kind of a big organization is going to offer you a different rate. But when it comes to blockchain-based development to any other core tech development, let's say .NET or C# or even just Java as well, we have a slight difference in the range of the salary that's being provided. So the blockchain-based developer or blockchain developer is usually highly paid. And one of the core reason is not that the technology is booming only, but also the supply and demand thing. When you talk about the blockchain ecosystem or blockchain-based developers, the supply itself is like very small and the demand it's like very huge. So if we talk about the demand outgrows the supply a lot. So demand is growing very rapidly, but the supply of the development or the supply of the developers is not very high. That's why it's one of the highest paid when it comes to any of the development side of into this whole software development side. So which companies and how companies are using blockchain-based technology? Again, that's a very common thing. That's IBM, Microsoft, and they are using in a different way, let's say for trade finances. And we have some countries that they are using, let's say Australia and Estonia is very famous. You can explore a little bit about Estonia's case study, how they have revolutionized their whole health ecosystem, the smart card that they have for their citizens or for the residents. And then we have a lot of things that's also evolved in Dubai also, with their Smart Dubai initiative. They have gone paperless with the initiative of paperless Dubai. So a lot of things that's happening in different regions. It's not just one or two countries. Most of the countries, China has also used this technology in a lot of different ways. So you can explore with how these technologies work in different countries and different companies, just to have a better understanding of the potential of this technology. And if you are convinced enough that, okay, this technology is very booming and the support from the government is very high, then you are satisfied what you are doing and where you are investing your time. That's very important. And you are motivated enough, you are going on a right track, you will be able to do it very easily and very happily. So that's a little bit of what we can discuss in our today's session related to how you can be a blockchain developer, who is a blockchain developer, and what are the steps to becoming a blockchain developer. So this is about our today's session, but we have different courses in our Simplilearn course as well, in our Simplilearn training programs that you can follow and that you can look up to. So you will be able to understand better of what's being provided by Simplilearn as for this blockchain-based technology. So I wish you all very good luck. Thank you so much for sparing your time for this video. In case of any comments and questions, just feel free to post it on this Simplilearn YouTube channel, and the team will be able to get back to you on the queries that's being posted. Thanks a lot for joining in. We'll come back for another video. Thank you.
And with that, we have come to the end of this video on blockchain in-depth tutorial. I hope you found this video informative and interesting. Please feel free to ask any questions you have concerning the topics covered in this video in the comments box below. Our expert will assist you in addressing your problems. Thank you for watching. Keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.